Hello, everyone. A very warm welcome to your own Silicon Valley Tech Talks show, your go to place to learn about technology trends and innovations directly from the leaders. This is your host, Faisal Batu from San Jose, California. In today's show, our topics are quantum technology and its convergence with AI. It's our pleasure to have Orlagh Neary as our guest today. Orlagh is General Manager at Microsoft for Quantum and AI go to market and ecosystem development. Orlagh has 20 plus years of experience at Microsoft and is well respected in the industry for driving new business incubation and go to market initiatives for new technologies. So, without any further delay, let's go and talk to Orlagh and learn from her insights. Hi, Orlagh. Welcome to our show. How are you doing today?
I'm doing great, Faisal. It's great to be here.
Yeah, thanks for joining. Yeah, Ola, so you've had a long journey at Microsoft, which spans across more than 2 decades, and you have spent most of this time incubating new businesses and driving go-to-markets for zero to one initiatives. So tell us a bit more about this journey, and also tell us about the incubation culture at Microsoft.
Oh, yeah, I'd love to. And you're aging me now, Faisal, 2 decades. It's like an eternity. But I guess I started my career at Microsoft actually in engineering, localization engineering. And I wanted to get more into the sales and marketing side of the business. So I started working as a speechwriter for one of the VPs on the cutting edge of developer technologies. And so from there, I had a great sponsor in my manager, and I've been really focused with her and the team for almost 2 decades on growing businesses, either mature businesses, right, like Visual Studio, SQL Server, to I guess in the last decade, Faisal, it's been more focused on incubating, like you said, new businesses. And so I feel really fortunate to have had a front row seat to introducing new technologies like Microsoft AI and now quantum. And I guess in terms of how I got an opportunity to do this, I think that speaks to the culture at Microsoft, right? You don't really have to be an engineer to be on the front row of innovation at Microsoft. It really is an interdisciplinary approach to creating and developing innovation. And I don't think many people know actually that Microsoft has an actual research department. So Microsoft Research has been around for about 30 years. And actually, Quantum is, I think it's the longest running research program. So, in terms of not just having an interdisciplinary approach to innovation, I think it's perseverance too, right? And the willingness at Microsoft to play the long game. Inside of Microsoft, we also are encouraged, with this concept of like ideas can come from anywhere across the organization. So hackathons are a big deal at Microsoft, where folks from across the org and across teams can come together to have sprints around developing ideas and figuring out if it has any business viability. And then outside the hackathons, we actually have a program. It's like an incubator program called Microsoft Garage or Garage. Because I'm Irish, it's garage versus garage. And so Microsoft Garage, where you can go and like it means you can tinker around with your ideas and invite people to help you with it. So it's somewhat unique to have this freedom to ideate, to dream. And then if you have the courage, the perseverance, the resilience to advocate for new paths, that's tough too, being the first to ask your boss, hey, look, I have this idea. I know we're spending all our money over here, but any chance that we could spend money here? And here's my thought. I mean, it's a tough road, but it is one that I think has been super rewarding, at least for me. Full of risk, to be on the cutting edge of stuff that may or may not pan out, but a ton of reward and a ton of learning.
Very exciting. A lot of people are not familiar with what quantum computing is, right? So, for those listeners, can you briefly tell us what are the key differences between quantum computing and traditional computing in practical terms?
Gosh, no, by no means am I a physicist. So, like, for your listeners, warning, this is not a master class in quantum. But for me, I guess I've been working on quantum for the last 3 years. And when I first started on it, I was just blown away by the brain power in the room. It has been really fascinating and just such a privilege to work with some of these most renowned physicists in the world. And so what they're working on is their lifelong passion, right? Quantum computing, because there is a promise that quantum can solve some of the world's most, difficult challenges like climate control, new drugs to prevent diseases or cure diseases and stuff like that. And so the difference is the speed at which quantum can potentially solve problems. And so classical computing, I think everybody, all your listeners will understand that has bits, right? You can either be a 0 or 1. So a bit like a GPS, like you have to follow step-by-step instructions, go down this route, then this route, then this route. For quantum, throw the GPS out because a qubit can be both a 0 and a 1 at the same time. That's called a state of superposition. You can be in both states at the same time. But what makes quantum even more powerful is that the qubits can be connected no matter their distance. And that's called entanglement. And so what that means practically is that in quantum, it's essentially like having an amazing, highly communicative team that can explore many routes and many options at the same time. So if you think about things like drug discovery, where it's a really, really complex problem, but there's a narrow set of data or somewhat narrow set of data, you can explore all the different paths to get to your result much faster than a classical computer can ever get to that solution. So therefore, it creates new opportunities for businesses, for individuals, for humanity. And like what I'm most excited about between classical and quantum is that convergence. And I know we're going to talk about it in a wee bit, but that convergence of AI and quantum working together in this great symbiotic relationship where one benefits from the other, that will unlock a whole new world of possibilities. And I like today, I mean, I could talk about some use cases, but the honest truth is like we don't know all the use cases for quantum yet, much like we didn't know all the use cases for AI. Like the explosion in generative AI and how people are using Gen AI now, I didn't dream of all these different possibilities. So I'm so excited about, this hybrid future that we're on the cusp of realizing.
Mhm. So yeah, definitely, we are very excited about the innovations that could come from quantum computing and technologies. But what stage quantum is at right now,
Yeah.
and what are some of the industries which will benefit from it before the others?
Yeah, definitely ton of hype. As with any new technology, there's a lot. We saw a lot of hype around AI. We see a lot of hype around quantum. It has been in the news a ton, even more recently, Microsoft made a discovery of a new state of matter, which helped us create the new Majorana 1 chip. And so whilst there is hype out there, the science is real and the outcomes that the scientists are creating, they are absolutely real. The business outcomes will come, but they're not quite there yet. So it's very early days for quantum. There's a lot of debate as to when quantum will actually be useful. But most folks would say we're putting it at about 2030, if not sooner. So right now, my focus is on readiness, on readying an ecosystem for the potential of quantum. And so we launched a program called Quantum Ready in January to help our customers and non-customers get ready for a quantum AI future. And in part, that was inspired by our experience with AI when the team worked on AI. So one of the things that helped AI be successful was customers were ready to embrace it and adopt it, which involves when you're introducing a new technology that isn't just a new technology, it's a completely new paradigm shift, like AI was and like quantum will be. It's it requires a new culture in your organization, a culture that can break down silos, bring data together from all different parts of the organization, bring SMEs together from all different parts of the organization to help solve problems. And quantum requires similar type of culture to embrace it. So we're really trying to dial up our awareness and education efforts with customers. We're also trying to strengthen the ecosystem. So competition is great. Microsoft always embraces competition. And so we work with our competition, we work with partners on the hardware side, we're working with academia as well, where we're investing in research in various universities around the world. And we're working with government as well to ensure that the ecosystem is being built, it's thriving, and it's ready to scale quantum as it becomes more and more a reality. Maybe one more thing I'd say there is around the path, right? So not only are we working to educate customers, we're also helping bring together AI and HPC to help in a sort of a quantum inspired way, help customers realize new value and therefore help society and economies realize new values. So we're working with Pacific Northwest Laboratory on AI and HPC together to use AI to, like, there was about 32 million candidates for new electrolytes, and we dwindled it down to one candidate for an electrolyte that can potentially help replace lithium and create more sustainable, batteries. It was a fascinating body of work. What could have taken years and years and years of research, we were able to get down to under a year to get to that discovery of that new candidate for the battery material. So if you think about quantum, when quantum is real, pretty exciting in terms of the new drugs that could be discovered, new ways in which we can help climate control, new ways in which we can help sustainability.
Yeah, it was very interesting to learn that AI may accelerate the availability and readiness of quantum, right? But I would like to dive a little deeper on the convergence of AI and quantum. I know you briefly mentioned
Yeah.
few use cases, but what are some of the innovations or use cases that can come from the convergence of the two, quantum and AI?
Faisal, that's a great question. And so I think AI is really good at large data sets and in detecting patterns, right, in that data. What quantum's really good at is taking really complex problems and finding an outcome or a solution super fast. So in terms of applications, think about drug discovery, think about finance. One of the big things is post-quantum cryptography. I was at a conference last week, and I was talking to one of the ladies in Airbus, and they're looking at quantum for route optimization. So huge complexity in figuring out all the various routes, right? And so they're looking at quantum's potential to help them really optimize routes. As much as quantum will create new value, it also creates risk because the existing encryption methods that we're all using, to protect our data, our healthcare data, and all sorts of personal data is traditional encryption methods, which will become, once quantum becomes a reality, those typical encryption methods just won't stand up. And so really a big use case for quantum is on the flip side of that is helping customers prepare for cybersecurity attacks by creating and adopting PQC standards and getting ready now for that. So that's a big part of what we're also doing with our partners in the Quantum Safe program. So finance, healthcare, drug discovery, route optimization, sustainability, climate, and then who knows where else quantum and AI together will lead us with more and more use cases. But they're the ones that I'm the most familiar with right now.
Thank you very much, Orla, for joining our show. I'm sure audience learned a lot from your insights.
Oh my goodness, I hope so. Like I said, I'm by no means, an expert in quantum. My expertise comes in introducing new technology to the market, and I've been on an amazing learning journey with the quantum program. And I'm thankful to all of the scientists at Microsoft, for all of their incredible work and for the ecosystem as well. And Faisal, thank you so much for the opportunity today to share some of my thoughts on a quantum AI future. And I hope your listeners will find some value in it. So thank you so much.
You're very welcome. Thanks again.